All right, so section 5.2, multiplying rational expressions. I want to show you guys really quick what the problems are going to look like. Problems number 1 and number 2 would be considered simple problems because all you have to do is multiply across, and maybe cross cancel here and there, just kind of simplify. But it's not going to be anything that's too much work to do. So we'll do some of those for sure. You'll notice questions 3 and 4 are still considered relatively easy. There's not a lot of stuff going on in those problems, right? Just two little fractions. No big deal. All right. But then we get to these suckers right here, right? Now, what's the difference between like 5 and 6 and things like 7, 9, etc.? Notice how 5 and 6, they've already factored those for us. They already like took the numbers out, the parentheses are there and everything, and they're just saying, okay, simplify as much as you can and multiply, okay? But they already did like the work for us. Now they're just saying, okay, simplify, okay? So that's what 5 and 6 are going to be. So we'll do one of those. Maybe we'll do number 6 for you guys. And then look at number 7 on the top left corner. That has not been simplified. That's something I'm going to have to factor, okay? If you look at number 7 on the top left corner, you're going to see it's a trinomial. You're going to have to use the x method. So notice I'm going to have to factor that, right? And then clean it up a little bit. Same thing with numbers 9 and 10, right? And then 11 and 12, right? So I think there's 12 problems total. No, 14. So I'm going to see if I can do as many as possible for you guys today, okay? But yeah, they're gonna start real easy. Then they're gonna give you like some that are pre-factored for us, and then they're gonna give you some that you're gonna have to factor all by yourself. Okay, so let's start off we'll just do one of the easier ones. Okay. Now I do want to just remind you before I do any of these problems. So we're probably gonna do like question number. Let's do number 4. But just really quick. You see how number 1, it says 7 over 8n times 2n. If you have a hard time understanding how to multiply that, you can always rewrite it like this. Okay, 7 over 8n times 2n over 1. You can always do that. You know what? Let me just do this one, and then we'll do number 4 after. So you can always rewrite it. And now, you guys hopefully still remember how to cross cancel. If you don't, it's okay. You can multiply across. But if you can cross cancel, it'd be really great. Because right here, notice this n will cancel out with that n. And then this 2 and the 8, 2 goes into itself once, and 2 goes into 8 4 times. So if you rewrite your fractions, a lot of people don't do this step, but I'm just going to show it. That's what it looks like after I canceled everything out. I have 7 fourths times 1 over 1, which is 7 fourths. And your answer is B. Again, these are considered the easier problems because they don't make us factor anything. It's just simplify, okay? Just simplify as much as you can, and you'll be done right away, okay? The ones at the very end, those are going to take some time. Sometimes for some of those at the very end, you may have to use the X method like 3 times. Okay, so we'll see it. Now let's jump over to number 4. So this was number 1. Like I said, I didn't want to do it, but it's okay. Number 1 and number 3 are very similar. Look at number 3. Okay, very similar. Just make it 3 over 1. Simplify as much as you can, and you'll be done. But number 1 we did. We'll skip 2 because we're about to do 4, which is similar to 2. Okay, so let's go over here to number 2. I'm sorry, number 4. So here is the problem. Let me write it out. 4x over 6 times 8 over 9. So what you're going to want to do is before you multiply straight across and start doing the work, you're going to want to see if you can simplify this as much as possible. Okay, you might notice these two numbers here. Okay, I'm going to erase that right now. But 4 over 6, you can reduce it. Or you could also reduce 6 and 8. Okay, like that. It's completely up to you how you want to do it. Me personally, I like dealing vertically if I can before I go diagonally. So I'm actually going to reduce 4 over 6, okay? I can divide 4 by 2, so 4 divided by 2 is 2, and I can divide 6 by 2 as well, so 6 divided by 2 is 3, okay? So to rewrite my next step, this is a 2x over 3 times 8 over 9, okay? Is there anything else I can cancel? Let me move this up a bit. Can I cancel anything else? No, just so you know, you cannot cross cancel straight across. It has to be diagonal or vertical, okay? You cannot cancel side to side. Because sometimes people say, oh, 2 and 8. 2 and 8, you can reduce those. Like, oh, yeah, but not like that. They have to be diagonal or one on top of the other, okay? So, am I done here? Is there anything I can cancel out? I look good here, right? So let's multiply. This is 16x over 27, which is, I think, option C. So these are considered like the easier problems, okay? Nothing too big, nothing too complicated. Just kind of take your time, cancel stuff out as much as possible, and multiply. Right? I didn't have to do any factoring for this. Just maybe a little bit of a reduction. Okay? Now, let me show you a different problem. So, let's work on number 6. Okay? Let's do number 6. Now, 6 looks pretty complicated. Let me rewrite it here. That's over 4b times b minus 2 times b minus 2 over 3b squared. I'm going to kind of bring it up a bit. What can I cancel? B, did you say b over 2 or b minus 2? B minus 2, okay. Now, remember, you don't want to do this. You don't want to say cancel that with this. Don't do that, okay? You want to cancel vertically or diagonally, okay? So there you go. I got rid of those. Is there anything else that matches from top to bottom? Even diagonally? The 3b squared, right? 3b squared and 3b squared, those match perfectly. So I can get rid of all that. Is there anything else I can get rid of? Well, don't do these, okay? Don't say, oh, this b with that b, because remember, the only way you can get rid of the b minus 2 is by getting rid of all of it, not just a little piece at a time. So this is what this problem looks like. Up on top of the first fraction is just a 1 over 4b times b minus 2 over 1. Because we got rid of everything on the top left, we got rid of everything on the bottom right, so let's just put a number 1 there just as a placeholder. So if I multiply this out, this becomes b minus 2 over 4b. And that's option B. So notice this isn't too bad if it's already factored for you. The bad part, and not to say it's terribly difficult, but the bad part would be when you have to do all that by yourself, factor everything by yourself, okay? That's when it gets a little tricky, okay? So that was a medium type problem. I know you're kind of thinking, well, that looked hard, but it's not too hard because it's already pre-factored for you, okay? So you'll notice number 5 is very similar to that. We're not going to do it, but number 5 is already pre-factored for you. So you just got to cancel stuff out and simplify and multiply, okay? Now let's look at 7 and 8. So let's do number 7. Okay? We're going to do number 7. So p squared minus 9p plus 8 over p minus 10 times 10 over p minus 1. Now usually what I do is I ask myself, okay, this is two big fractions here. Do I have to factor anything anywhere. So if you don't mind, I'm going to start with the right side fraction, the one that's 10 over p minus 1. So the 10, I do not have to factor that at all. It's just the number 10, okay? So no big deal, no need to factor that. The p minus 1, I also don't need to factor that. I can just leave it alone. So notice the fraction on the right side does not have to be messed with, okay? Now let's look at the fraction on the left side, the p squared minus 9p plus 8 over p minus 10. Now, on the bottom, p minus 10, I can't factor that. There's nothing I can take out. But the top left corner, I can. So I'm going to have to use an x method, okay, with the p squared minus 9p plus 8. So a, b, c. A times c is 8. And b is negative 9. Two numbers that multiply to 8 that give me a negative 9 would be a negative 1 and a negative 8. Those two numbers multiply to a positive 8 and they add up to a negative 9. Do I have to divide by anything? No, right? Because my a term is a 1. So I don't need to divide. So my answer is going to be p minus 1, p minus 8. So let me write that down. P minus 1, p minus 8 over p minus 10 times 10 over p minus 1. You'll notice I like putting parentheses around my binomials. It's just a habit for me. Makes it easier for me to say like this is together and this is together, etc. You don't have to do it, but I just do it out of habit. So what can I cancel? P minus 1, right? This one with that one. Is there anything else I can cancel? Like you might want to say the 10s, but can I cancel the bottom 10, the one on the bottom left? No, because it's part of an expression. I have to get rid of p minus 10, not just the 10. So I'm done. This problem is finished. Let me just multiply. 10 times p minus 8 is 10 times p minus 8 over p minus 10. Notice that's c right there. Oops, I was going to block the whole thing. I wanted to block this here. So there you go. So notice you may have to factor your problems yourself. Okay? So that's okay. If you have to do a couple, then go ahead and do a couple. Now, as we move on to the harder problems, you might see more and more factoring. Okay? So let's look at number 9. Let's take a look at number 9. Because number 9 has a little bit of a trick to it. Okay? And it's not even a factoring trick. It's something that you have to try to do just to make things match up nicely. So let's rewrite this thing. This is 35 p cubed plus 21 p squared divided by 4 minus p times p minus 4 over 15p squared plus 9p. So I like to call it top left, top right, bottom right, okay, because we have two fractions there, right? So I want to look at the top left of my statement, meaning the 35p cubed plus 21p squared. What can I factor out of 35p cubed plus 21p squared? A p squared. I can also factor out a number. A 7, good. So 7p squared. I can take out a 7p squared from the top, okay? So if I take out a 7p squared from 35p cubed, that's a 5p. And then plus 3. That's what gets factored. Okay, 5p plus 3. Times p minus 4 over, all right, what can I factor out of the bottom right? A 15p squared plus 9p. A 3, and what else? A p. So 3p. If I factor out 3p, I end up with 5p plus 3. Okay? What can I cancel? Look diagonally, look vertically. What matches? All right, 5p plus 3. Thank you. That's gone. Is there anything else that matches, or maybe you think closely matches? All right, so 4 minus p and p minus 4, they almost match. If it was addition, I would say they match exactly, and I just have to cancel them out. But is it the same when you subtract and you just mix numbers back and forth? Like if I say 2 minus 1, is that the same as 1 minus 2? Are those the same answers? No, right? 2 minus 1 equals 1. 1 minus 2 is negative 1, right? The difference is a negative. Okay, so just to show you, if I do 5 minus 3, the question is it the same as 3 minus 5? Well, that's 2, and that's negative 2. So are they the same? No. How do they differ? A negative. That's it, right? Just a negative. So here's a nice little trick for you guys. I'm going to cancel p minus 4 and 4 minus p, even though they're not the same. But look what I'm going to do. I'm going to put a negative 1. I'm basically saying I'll cancel them, but I know the difference should be a negative 1. Okay? Because that's the only thing that's different is a negative. Right? Think of it. 10 minus 5 is 5. 5 minus 10 is negative 5. Right? 100 minus 10 is 90. 10 minus 100 is negative 90. The only difference is a negative. So I can cancel things that are subtracted that almost look identical, just their position is off. I can cancel them as long as I put a negative 1 in its place. Okay? So just do that. Make sure you put a negative 1. Not on both of them, just on one of them. So you'll see I did it down there. All right. Let me clean this up a little bit, if you guys don't mind. 7p squared over negative 1 times 1 over 3p. Can I get rid of anything else? Diagonally, vertically? Is there something else you see that maybe they have in common? A p, right? Well, they have the ones, if we cancel them out, they get replaced by 1, so don't even worry about those. But I can get rid of one of the p's, right? This p here, and this will become a power of 1. Because the p on top has 2 of them, and on the bottom there's only 1. So if you get rid of 1 each, then you're still left with 1 on top. So we're pretty much done here. 7p over negative 1 times 1 over 3. That gives me negative 7p over 3, which is right there. So you see what I mean by these can get a little bit more complicated, right? Once we get to the last couple, they start to get kind of on the difficult side because you have to break stuff down, cancel, then break more stuff down. And it can get a little complicated. So take your time with it. Don't rush through these last problems because you can mess up pretty easily. Okay? And it's usually just mistakes that you make by accident. Like, oh, I should have done this. Now I see it, right? So just take your time with them. The first ones, sure, you can go through them pretty quickly, but towards the end, they get a little tough. Okay? So, all right, let me show you guys another one that's going to be even a little bit more complicated, and then I'll let you guys do some work. Let me see. We might do 11 because that one looks like it's going to be pretty tough. Yeah, we'll do 11. 13 and 14 are not too bad. Let's look at number 11. So can you tell that for number 11, I'm going to have to use the X method 3 different times? Right? Top left, top right, bottom right, all those X method. Okay? So let me rewrite here. X squared minus 11x plus 18 over 9x minus 18 times x squared minus 3x minus 54 over x squared minus 18x plus 81. So I'm going to have to use the x method. Let's start with the top left corner, okay? Top left, x squared minus 11x plus 18. So I'm going to kind of do a little bit smaller than usual. That way I can fit as much as I can. So my ABC, that's going to be 1, negative 11, and 18. So 1 times 18 is 18. And negative 11 is right there for my B value. Two numbers that multiply to 18 that add up to negative 11 would be what? Negative, did you say negative 9? Oh, okay, I'm sorry. There we go. And those are good. So, all right. That gives us x minus 2, x minus 9. So perfect. Let's write that down. X minus 2, x minus 9. Do I have to use the x method for the bottom left of this fraction? No, right? Just a common term. What should I take out? Say again? Oh, I don't want to take out 18, but I think I know what you're saying. Between 9 and 18, what number do I factor? A 9, right? But it will affect the 18. So the 9 goes out. This will be x minus 2. Notice how I can cancel out those x minus 2's right there? Okay, I'm not going to do it yet, but that will happen. All right, let's look at the top right. My A, B, C for the top right. So let me put another little x method here. 1 times negative 54 is negative 54. And negative 3 goes here. Anybody know two numbers that multiply to negative 54 that add up to negative 3? Negative 9 and a positive 6. Because 9 times 6 is 54, right? If we need it to be a negative 3, then the 9 has to be negative. So here we go. That'll be x minus 9, x plus 6. So let me put that right here. X minus 9, x plus 6. And now one more x method. So again, this would be considered a hard problem. Not because, oh my gosh, I don't know how to factor. Hopefully you do. Just because it's a lot of work, right? So let's do one more x method here. My ABC's A, B, C. So 81 goes here and a negative 18. What numbers multiply to an 81 that add up to a negative 18? All right, negative 9, good. So this will be x minus 9, x minus 9. Let me put that right here. Okay. So here's where you're happy because you're like, good, I factored everything. Now let's just get rid of stuff. So what can I get rid of? X minus 9. Notice this one can cancel with that one, and this one can cancel with that one. What else can I get rid of? X minus 2. Perfect. Is there anything else I can get rid of that's pretty obvious or no? I don't see anything, right? Let me rewrite. 1 over 9 times x plus 6 over 1. Because remember, we canceled out everything on the top left and on the bottom right. So we just got to replace it with 1s. Since I can't cancel anymore, then my answer is x plus 6 over 9. And that would be part A for this one. So I'll give you guys your homework right now.